This is a video walkthrough for the code to run both a correlation and then a regression. We'll start off by looking at correlation, and to do that we'll be using the MT-CARS dataset, which comes loaded into our array already. So we'll start by assigning the data to an object called data. And we see that it's run, and here is our data object, 32 observations of 11 variables. So we can see what is included in here, so what are our variables we're working with. We can see that each row is a different type of car, and it gives us things like miles per gallon, cylinders, horsepower, weight, etc., etc. And so we aren't going to do a correlation on this whole entire data set. We're only going to use a few of them. So we're going to look at miles per gallon, which is this column. We're going to look at horsepower, which is this column. And we're going to look at weight, which is this column in tons. And so we need to subset our data because we don't want the rest of these columns. What we'll do first is load up tidyverse so we can use some of the functions and the pipe within that. And here is where we are subsetting our data. So we're making a new data object called data1, and we say, please assign our dataset to that, send it on, but we're selecting only these three columns. So it says select the combination of miles per gallon, horsepower, and weight. So when we run that, we see we have a new data object over here. We still have 32 observations, but now we only have 3 variables rather than the 11 that we started with. We can check what that looks like just to make sure everything is to our liking. And again, we see car type is over here, but now we only have miles per gallon, horsepower, and weight. So what we're going to do first is examine the data. So we can look at the relationship in between miles per gallon, horsepower, and weight by using a scatter plot. And with a scatter plot, you are comparing the relationship of one variable to another. So we're going to have to create a number of different scatter plots to look at each of the different possible combinations between these 3 variables. So we'll first load up ggplot because we'll be using that. And here is our first scatter plot. This is going to be comparing miles per gallon to horsepower. So we see we're calling ggplot. This is our data. So data1 is what we'd like to use. And this aesthetic line right here is saying we would like miles per gallon to be on the x-axis and horsepower to be on the y-axis. And then we send that on and we say that we would please like a geom point, which is the way of saying that we want a scatter plot. And in here, we don't need any additional arguments. So if we were to run this, then we get a scatter plot over here. As we see, miles per gallon along the x-axis, horsepower on the right, and we see it looks like a slightly perhaps negative trend, semi-linear, kind of curvilinear. But this is the trend of how miles per gallon relates to horsepower. We can create another one looking at horsepower as compared to weight. And that, horsepower now along the x-axis, weight along the y. This looks like a positive linear relationship. And then we can compare miles per gallon to weight. And we get much more of a linear relationship and negative relationship. So that's all fine and dandy. We created 3 separate scatter plots. That can be really annoying when you have a lot of different combinations to do. So what you can do instead of using ggplot is use this pairs function. and you are stating your data, you put this comma here to say that you'd like it to use all rows, please, but these are the columns you'd like it to use. So when we run this, we get this right here. And so the way that you would interpret this is here is miles per gallon. Like this whole column is miles per gallon along the x-axis. This right here is miles per gallon along the y-axis. So if we were to look at this plot right here, we have miles per gallon along the x-axis, and then we have horsepower along the y-axis. So you notice that these look very similar because they're comparing the same two variables. If we looked at this one, we still have miles per gallon along the x. This time we have weight along the y. So this is a way to kind of get all of your comparisons all in one figure. It's a little bit less visually intuitive than a single plot, but it's a lot easier to run rather than making a lot of individual scatter plots. But once you've examined kind of how the data look, we can run a correlation. So maybe we would like to look at the correlation between miles per gallon and horsepower. So we're just looking at the correlation between those two. And we can run this, scoot this up a little bit, and we see it tells us we ran a Pearson's product moment correlation. This is the data we used. We have degrees of freedom, we have p-value, we have a 95% confidence interval, and this right here, oh, come on, right there, is the correlation. Remember, correlation is going to range from -1 to +1. So this is a pretty strong negative correlation. We can also, rather than running it just between two variables, we can run it similar to how we did here and get a correlation matrix for correlations among all of the variables. So to do this, we'll use the Hmisc package. So we'll load this up first. It's going to think about it for a second down here. And what we'll do is we'll be using the rcore function from the package. And we're saying we would like it as a matrix, and we would like the data to be run is data 1. So our selected data. We're saving it out as an object just so we don't have to rerun this every single time we want to investigate it, or if we wanted to perform further things on it. So we can run this, and we see it ran. We see we have a new data object up here. And if we wanted to view the results, we could do it this way. And so what we get, scoot this up again, is we get two different tables. So here is the actual correlation values. So we see that the correlation between miles per gallon and horsepower, which is what we tested up here, is -0.78. The correlation between miles per gallon and weight is -0.87, and between weight and horsepower is 0.66. We have to look at a separate table to determine the p-value. And so there's p-values of 0 here, and all of that is meaning that it's less than 0.001. So that is one way that we can see it. Another way that we can see to have everything kind of in the same table is use the correlation package. So we would load this up, and if we ran it, so it's just simply saying correlation is the function, and we just feed it the data that we want to use, then it gives us a table like this. So if we look at just a single row in the table, it's saying if we're comparing miles per gallon to horsepower, this is our correlation, -0.78. This is the 95% confidence interval of that correlation. our t statistic, and our p-value. And then the same for all the other rows. So that is how you would run a correlation. A couple of different options there depending on how you would like your output to look. If we shift over to running a regression, linear regression, we're going to again use the trees data set. So we used this earlier, but we'll be reassigning it to a data frame. Again, trees is just a data set that comes native in R. So we'll do that. We see we have a new data object up here. And we'll get a look at it. We'll get a look at the relationship. And since we use ggplot up here, we don't have to recall it in. And so here we're looking at the relationship between height and girth, or diameter of trunk. So we're saying this is the data we'd like to use, please. We would like X to be height, Y to be girth, and we would like a scatter plot to evaluate the relationship. So if we run this, and with this, we can see that there appears to be a sort of a positive linear relationship between those two variables. It appears that as height goes up, as does girth. And so we can make a linear regression model, and we are saving it as an object. And this is, again, a good habit to get into, so that way you can do further testing on it, and you can get some summary things from it, and you don't have to constantly be running the model. This is especially important for large and complex models. So we're going to make an object called model. We are going to run a linear regression, so LM, and we're going to provide it the formula. So we want to look at girth as a function of height, and this is the data we are using. So if we run this, again, we don't get any output down here. We see we have a new object. We can look at that output, and it reminds us this is what we did. These are the coefficients, so the intercept and the slope value for height. And we could also get a summary of this. So this is, summary of our model. And so if we were to look at that, this gives us, some more information. And so it gives us a little bit of information about the residuals, the coefficients. So this is particularly useful right here. So there's our intercept. There is the slope value for height, the standard error, the t-value, and the p-value for each of them. And it's saying here that, height is going to be a significant predictor of girth. Other information that we can see down here is degrees of freedom, our R squared value, and our F statistic, with associated p-value. So we would say that this data, or this model, better fits this data than a model with no variables. So it's an improvement over nothing.